Good afternoon. So last week we discussed the Oracle tool. So in that we saw how to create a table, how to drop it, and how to add data into it. So today we shall extend that particular discussion. So we were discussing a company database. Okay, the various data types that can be used for specifying the attributes so is mentioned over here. So let us look into an example of the dependent table. Okay, so in order to create the dependent table and also the department table, so both we shall see. So the not null, so in our previous week discussion, we saw what is the use of this not null. So whenever an attribute value is specified as not null, which means we cannot insert a blank or an empty value for that particular attribute. So if we insert a blank value or null value for that particular attribute, then the database tool will raise the errors. So the various attributes in department table include the name of the department, so which is not null, department number, it is an integer, again it should not be null, MGRSSN, that is a character. So MGRSSN means manager SSN, manager start date. So these are the attributes of department table and few attributes are not null. So again, not null is also another sort of rule on the database. So hence it is also called as a constraint or it is part of a constraint. So next, another alternative creation of the department table. So here we'll try to specify the primary key attributes and secondary key attributes, along with that the foreign keys. So foreign key is also called as referential integrity constraint. So the department table, again another way how we can represent it is department name, variable character, not null. So in our previous example, if you see over here, we have used both variable character and character. So we shall see the difference of these two data types in today's class. Okay. So department number, so it is integer, not null, manager SSN, manager start date. So primary key department number. So we are designating the we are designating the department number as the primary key over here. Okay, so it is the primary key, which means that department number should not repeat. But if we make department number as primary key, the name can repeat. So instead what we'll do is, so we'll also choose the department name as unique. So in last week we have studied what is primary key and unique. So primary key makes a particular attribute as unique. So both are same, which means we cannot repeat department number as well as we cannot repeat the department name. So but still there is a distinction between the two terminologies, that is the unique and primary key. So first thing is, if we designate any attribute as primary key, first thing is it should not be null. So a primary key cannot be null. But for a unique key, null is allowed unless we have declared a not null over here. Then whenever we are declaring or specifying a foreign key to this department table, that foreign key should be referred to the primary key only, not to unique key. Because in some other table, if we are specifying a foreign key to this department table, then we will specify it for department number and not for the department name. So hence we'll declare the department number as the primary key and the other one as the unique key. So in whatever tables we create, so we will specify those attributes which are referred by other table as primary key, and other attributes which needs to be unique are declared as unique. So foreign key is present in department table, that is foreign key is the manager SSN, refers to employee in employee table, so it is the employee number or SSN. So however we have declared, so that attribute can be specified over here. So this is how a department table we can create. And remember, whenever we are making any attribute as a foreign key, that attribute in the employee table should be its primary key. So this should be primary key in employee table. So now let us look into various data types. So various data types includes integer, short form values int, small int, float, real, double, precision, and we can also specify the decimal values, or if in programming terminology we call them as floating point numbers, like in our previous example, POC marks, so our percentage. So it can be represented like 90.8. So this 0.8, whenever we are mentioning, so it makes it as the decimal number. So whenever we want to represent such kind of numbers, we'll use the decimal or numeric format. So in these data types, whenever we are specifying, two values needs to be specified, that is I and J over here, you can observe here. So here I is called as a precision, and this J is called as the scale. So this is J. So scale and precision. So what is scale and precision? So a decimal digit will be present over here, and the number of digits present before the decimal, it is called as precision. So it is called as precision, and the number of digits uh, present after the decimal, it is called as scale. So precision and scale. So whenever we are specifying a decimal or numeric values, we must specify the precision and scale. So how many decimal digits we will be using? So for example, this PUC percentage, if I want to mention it as an attribute, we must specify that is 2 comma 3. So if we are not using the decimal, then by default, this scale value, it will take it as 0. So if you declare it as integer, the scale will become 0. If you want the scale, then we have to use either decimal or numeric values. So again, the difference between integer and small int is the size or the maximum value which we can store for that particular attribute. Okay. So next is the character and variable character. So this all the string attribute types are represented as the character or variable character data type. So these are associated with a number, that is the n. So n indicates the number of maximum characters that can be stored in this particular variable. So now let us consider two examples for discussing this. So consider USN. So in our application of a college database, whenever an USN is specified, we know that its format is fixed and it will take 10 characters. So that is fixed. There will be no USN in the database which will take 9 characters, or USN there which will take 11 characters. So there is no lesser than 10 or greater than 10. So it is fixed. So when we have such situations or such attributes, we will go with the character, that is character type. So we will declare USN as a character type. So when a USN is declared as character type, it indicates that the 10 character space is reserved in the memory or it is consumed in the memory. If I insert one student entry into the table, then this particular USN will consume 10 characters. Now, let us assume if we insert only 8 characters for this USN, anyway, we have not specified 10 as a constraint. So let us consider we have inserted a USN value which is having 8 characters. Then what happens? Still in the memory, 10 character space is reserved for the USN. But we have inserted only 8. So for example, let us consider like this. We have inserted a USN, something like this. So even though this is an invalid USN, but let us assume this is a valid one for the application. So it is 8 characters. Now, what happens if this particular value is inserted? So when this particular value is inserted, it will be consuming 8 character space, but USN we have specified it as 10. So what happens is additional 2 spaces will be reserved for this. So additional 2 spaces will be reserved. So again it happens 8 plus 2, this will be 10. So whenever an attribute is declared as character, so whatever number we specify, that much memory will be reserved. So even though we store the lesser number of characters, the other remaining space will still be allocated to that particular attribute, and it is wastage of memory. So that is how memory allocation happens in character. So when we declare character of n. So when we declare a name, so let us consider we are declaring a name as character of 25. So which means 25 character space is reserved for name. So even though the name that is stored in the database is less than 25, but still the 25 space will be allocated. For example, so let us consider this is the name we are storing. So Ramesh having 6 characters. So what happens if we look at the memory organization? So 6 space will be stored and the remaining 19 spaces will be stored with blank. Okay, so it will be blank. So 6 characters, 19 blanks. So while comparison, so these blanks are ignored. Okay. So if we are comparing a name in any of our queries, then these blanks are ignored. So this is how character works. Now let us look at the varchar. Okay. So when we declare any attribute as varchar, so let us consider again our name attribute. If we declare it as varchar of 25, so what happens is it will not allocate the memory for 25 characters. So instead what it do is, for example, if again let us consider the same name. So a name with 6 character, that is Ramesh. Okay. So when we specify this as a variable character with 25, so this 25 indicates the maximum number of characters that we can store in this particular attribute. Suppose if we are storing lesser number of characters than 25, so in our case it is 6 characters, then memory will be allocated only for 6 characters. Then you may ask, what about the remaining 19? So the remaining 19 spaces will not be allocated. So this is just like a variable character. So which means we are varying the size of this attribute. Now, if we declare name as a character, and let us imagine we are storing 2 names, one name with 6 characters, another with 10, then the total memory that is allocated in a character is 2 into 25, that is 50. But if we declare it as a variable character, then it is just 16. Okay. So variable character will allocate the memory only for the characters which we are specifying. So the advantage of using variable character is it saves our memory. So as a application developer or database designer, so we have to choose between a character and a variable character by considering these memory requirements. So if our application is using a fixed number of characters, just like USN, we can directly go with character. And if we don't know the fixed number of characters that an attribute takes, so then we can go for variable character. So again, memory is the advantage, but there is a disadvantage, that is the time required for processing a character is less, whereas the time required to process a variable character will be more, because each one will be having different sizes, so they are stored somewhere in the memory with linked lists concepts, so the retrieval will take time. So this is the difference between the character and variable character. So next uh, data type, it is the bit string. So suppose if we want to store a bit pattern, so binary bit pattern like this, then we can use the this data type bit. So bit of n, bit varying of n. So both are same. The only difference between them is, so bit of n is just like a character of n, and bit varying, it is just like variable character. So the amount of memory allocation is fixed in bit, whereas it is varying in bit varying. So we can specify this bit values using b followed by a single quote. So this kind of values can be specified. So binary values can be specified using bit string. Okay. So then Boolean value. So true or false can be specified in using Boolean values. So in RDBMS or in structured query languages, so it is three levels of, or three kinds of logic. So is utilized. So first logic is true, okay, and the second logic is false, and another logic we have that is unknown. So unknown. So there are the three levels of logics. So this unknown level of logic is used for null values. So since we have the concept of null, so concept of null is used for those attributes for which we don't have the value now. For example, email ID. So currently we don't have an email ID of a student. So when we are storing the student information, in place of email ID, we will store the null value. So why we have utilized null? Because we don't know the values. So that null concept will lead to another level of logic, so that is unknown. So we have three logics in databases, that is true, false, and unknown. Okay, so the Boolean values for attributes can also be specified using this. So in our student case, so we can utilize this particular Boolean variable for graduate. So if we want to add one more attribute, that is graduated or not, for each student, we will be storing that. So we can use Boolean type and specify the attribute values as true and false. Okay. So another kind of attributes, so we can have, so that is the other data type, that is date, time, and timestamp. So we can store also the date type. So date, we will store the format for storing the date is like this. So that is year first, then month, then followed by date. So year 4 digits, month 2 digit, and date. So some DBMS packages will use the alternate representation, that is 4 digit, and month is specified as instead of number we will use JAN for January, FEB for February, like that. So that is also allowed. So whenever we are specifying the date, so it is specified inside a single quote. So just like strings. So this format is followed in many of the database packages. So if I want to specify today's date, so it will be 2020, then followed by the month, that is September, then followed by the date 28, and this is put inside a single quote. So this is date. And time also we can specify. So time is a data type. So time is specified in this particular format, that is HH colon mm colon seconds. So that is hour, minutes and seconds. So again, this is also specified in a single quote. So the usage of date and time is useful whenever we are comparing a date. So we can compare the dates just like how we compare the numbers, greater than, less than, equal to. So all those operators will work on date data type also. So then comes the concept of a timestamp. So this timestamp includes date, time, along with that one more precision or scale for seconds, or you can call it as a microseconds. So all the details are captured in a single attribute, that is date, time and the microseconds details. So that it becomes the timestamp, and timestamp is predominantly used whenever we are storing the log data. So at what time a user logged in, or at what time, what date, at what second a transaction has happened. So that minute detail of time can be captured using timestamp. So along with all of them, so we can also capture the time zone. So time zone indicates the exact time with regard to that particular time zone. For example, if we are following Indian Standard Time, so we are 5.5 hours ahead of the Greenwich time or GMT. So that can also be specified uh, along with the time. So suppose if we want to store the date of birth of a student, so we can use date data type. Along with that, we can also store date of admission, date of graduation, anything. So this is about the various data types that are present in the SQL, that is structured query languages. So then drop table commands. So we have already studied this drop table. So, but a few things we need to study, that is the what is this cascade and restrict. So these things we shall study in tomorrow's class. Okay. So we can stop over here. So you can enter your names in the chat for attendance, and you can exit.